Just like numbers, there are also different operations in sets. Learn them here in Mathematics of Engineering. The first operation is union, notated with the symbol U. Union means all elements in both sets A and B. If we illustrate this operation in a Venn diagram, showing set A with elements A, B, C, D, and E, then set B has elements D, E, F, G, and H, union is taking into account all the elements in both sets, that is, A, B, C, D, E, F, G, and H. The next operation is intersection, notated with a reversed U. Intersection includes all elements which are present in both sets A and B. With the same illustration, we account the intersection of sets A and B as the elements D and E. The third operation is difference. This connotes all elements which are in the first set A but not in B. In case we are solving for A minus B, we take elements of set A as A, B, C, D, E, then subtract set B with elements D, E, F, G, and H. This would leave elements A, B, and C. This is A minus B. Like subtraction, difference of sets isn't associative, which means A minus B has a different set of elements from B minus A. With reference to B, we take away elements coming from set A, leaving the elements F, G, and H. There is also symmetric difference, which includes all elements in the union of A minus B and B minus A. From the previous solutions, A minus B contains elements A, B, and C. Then B minus A has elements F, G, and H. If we take the union of these elements, we get the symmetric difference of A and B as the elements A, B, C, then F, G, and H. The last operation is complement, denoted by a bar before the set, A with a superscript C, or an apostrophe. Complement considers all elements in the universal set which are not in the set considered. Say we have a universal set of elements A until K. Then set A is still A, B, C, D, and E, while set B has D, E, F, G, and H. The complement of set A for this case would contain all elements in the universal set except those in set A. That would be F, G, H, and I, J, and K. In case we also check the complement of set B, that would be everything in the universal set except that of set B. So the complement of B has the elements A, B, C, I, J, and K. There are only 4 operations of sets. Here is an example of such operations. Let the universal set contain all natural numbers. Then set A contains all x, where x belongs to natural numbers and it is greater than or equal to 7. Set B is all values of x, such that x is a natural number and it is odd. Set C is all values of x, which belong to natural numbers and they are multiples of 3. The last set D is a collection of all x where x is a natural number and it is even. From the given sets, we are to determine a list of operations as shown, and our answers should be written in roster form. Before answering the required, let's evaluate the given sets. Natural numbers mean positive whole numbers from 1 to infinity. With set A being a natural number, and it is greater than or equal to 7, the smallest element is 7 way up to positive infinity. Set B is then considered as positive odd numbers from 1, 3, 5, 7 until positive infinity. The third set C is a positive multiple of 3, and that would start from 3, 6, 9, and so on. Set D have positive natural even numbers 2, 4, 6, and so on until positive infinity. In order for us to visualize this better, we use a Venn diagram. Having 4 sets in the universal set, we require 4 circles. We populate the diagram by placing each number. 1 is found in set B only, the group of odd numbers, and nothing more, so this would be placed in set B without any overlap. 2 is an even number, which can only be found in set D. 3 can be found in both sets B and C, so we place it in their overlap. 4 is only found in set D. 5 is only positioned in set B. 6 can be placed in the overlap of sets C and D. 7 can be found in both sets A and B. 8 belongs to set A and set D. 9 is found in set A, B, and C. 10 is placed in the intersection of sets A and D. 11 is in the overlap of A and B. 12 is found in sets A, C, and D. 13 is common in both sets A and B. 14 is from sets A and D. Then 15 is found in sets A, B, and C. We can take more numbers from practice, but let's start with the task. The first operation is the intersection of sets A and B. Using the Venn diagram, it is easy to visualize the part to consider. The overlap of sets A and B is the common elements from the natural numbers starting at 7 and the odd numbers starting at 7. Similar with those shown on the overlap, the intersection of sets A and B are elements 7, 9, 11, 13, 15, and all other odd numbers is starting from 7. Basically, this is just like set B less the first 3 elements 1, 3, and 5. The second requirement is the union of sets A and B. Since most elements of set B are found in A, you can have the union as set A, then add the first 3 elements from set B, the elements 1, 3, and 5. The third task is the complement of the union of sets A and B. Complement considers the elements not included in the union of sets A and B. So from the Venn diagram, we get elements 2, 4, and 6. How about if the complement is placed in individual sets A and B? Then we take the intersection. Visualize the Venn diagram. With the available elements, the complement of set A are 1, 5, 3, and 2, 4, then 6. The complement of set B would highlight elements 8, 10, 12, and 14, with 2, 4, and 6. The intersection focuses on the common elements in both complements, and those are elements 2, 4, and 6. Requirement is to take the intersection of the union of sets A and B with C. Following Gemda's operation, take the union of A and B first, then observe its intersection with set C. That would give the elements 3, 9, 12, and 15. Task F asks for the union of the intersection of sets A and C with the intersection of sets B and C. The intersection of A and C give elements 9, 12, and 15. Then the intersection of B and C have 3, 9, and 15. Taking the union of these two intersections are mostly the multiples of 3 except 6, as 6 is not a part of set A. For the next requirement, we are to determine the intersection of sets B and D. Set B is the group of odd numbers. Set D is of the even numbers, which can never have any common element. Thus, the intersection of sets B and D gives a null or empty set. Requirement H is the complement of the intersection of sets B and D. As complement means the elements not included in the intersection, and since the intersection is a null set, the complement is basically all elements in set A plus the elements from 1 to 6, which is technically all natural numbers. The next operation is set A minus set D. That is taking set A, then place set D where their overlap would need to be taken out, leaving the elements 7, 9, 11, 13, 15, and so on. These are elements of set B, but without 1, 3, and 5. The next is again set difference of B and D. So take set B, and then remove elements and overlap of set D, giving elements 1, 3, 5, 7, 9, 11, 13, and 15. This is just like set B. Task K requires the union of the difference of sets A and D with the difference of B and D. As the two quantities have already been determined earlier, we can simply place them in the Venn diagram and take their union. That would be considering elements 1, 3, 5, 7, 9, 11, and so on. The same elements found in set B. Requirement L takes the difference of the union of sets A and B with D. Take the union of sets A and B. Then we take out the circle for D, giving the elements 1, 3, 5, 7, 9, 11, and so on. Again, the same elements of set B.